Okay, the first problem, we have the positions of objects provided as a function of t. We have these 5 functions, and we want to find what is the velocity in each case. My first function, x1 of t, is cos hyperbolic t plus sine hyperbolic t plus t squared. So to find v1 of t, we take the derivative of the function with respect to time, which is cos hyperbolic t plus sine hyperbolic t plus t squared prime. So I have to take the derivative of each of the functions, cos hyperbolic t prime plus sine hyperbolic t prime plus t squared prime. The derivative of cos hyperbolic is sine hyperbolic. The derivative of sine hyperbolic is cos hyperbolic. And the derivative of t squared is 2t. So that is the expression of the velocity for the first case. x2 of t is the following: t sine t plus t cubed. v2 of t equals the derivative of the position. So I have to take the derivative of t sine t plus the derivative of t to the power of 3. Here I use the product rule, so I have the derivative of the first function times the second function plus the first function times the derivative of sine t plus the derivative of t cubed. The derivative of t is 1, so I have sine t plus t times the derivative of sine is cos plus 3t squared. So v2 of t is sine t plus t cos t plus 3t squared. x3 of t is ln t plus 5 plus arctangent of t. To find the velocity, I take the position and I differentiate with respect to t, so I have the derivative of ln t plus 5 plus arctangent of t derivative, that's 1 over t plus 5 plus 1 over 1 plus t squared. So v3t equals 1 over t plus 5 plus 1 over 1 plus t squared. x4 of t is the exponential to the power of t sine t. So the velocity v4 is the derivative of the position with respect to time, e to the power of t sine t derivative. So that's e to the power of t derivative sine t plus e to the power of t sine t derivative. The derivative of e to the power of t is e to the power of t plus e to the power of t cos t. So v4 of t is e to the power of t, I take it as a common factor, sine t plus cos t. And x5 of t e to the power of t cos t. So the velocity is the derivative of the position with respect to time, the derivative of the first function times the second function plus the first function times the derivative of the second function, e to the power of t cos t. Cos, the derivative of cos is minus sine, minus e to the power of t sine t. And from here I have that the velocity is e to the power of t times cos t minus sine t. Now we go to the other part. We have the velocity of moving objects and we want to find the acceleration, so we have to differentiate the velocity with respect to time in order to get the acceleration. So t v1 of t equals t squared e to the power of t. So to find the acceleration, we take the derivative of the velocity with respect to time. So that's the derivative of the first function times the second function plus the first function times the derivative of the second function, 2t e to the power of t plus t squared e to the power of t. I can take common factor e to the power of t and I have 2t plus t squared. So the acceleration is given by this formula, e to the power of t, 2t plus t squared. v2 of t is ln t plus t to the power of 5. So the acceleration is the derivative. I take the derivative of ln plus the derivative of t to the power of 5. So that's 1 over t plus 5t to the power of 4. v3 of t equals t to the power of 5 sine t. So the acceleration is the derivative v3 prime, the derivative of t to the power of 5 sine t plus t to the power of 5 sine t derivative. The derivative of t to the power of 5 is 5t to the power of 4 sine t plus t to the power of 5 cos t. Two more cases to go. v4 is t to the power of 3 cos t. So my acceleration is the derivative of the velocity. So it's t to the power of 4 derivative cos t plus t to the power of 4 cos t derivative, t to the power of 4, 4t cubed cos t minus t to the power of 4 sine t. The derivative of cos is minus sine. And a5 of t and the last one, v5 of t equals ln t cos hyperbolic t, ln t sine hyperbolic t, sorry, ln t sine hyperbolic t. ln t sine hyperbolic t. So the acceleration is the derivative of ln t sine hyperbolic t plus ln t sine hyperbolic t derivative. So that's 1 over t sine hyperbolic t plus ln t times cos hyperbolic t. And that is my acceleration.